around. Oh my God. Ladies and gentlemen, welcome everyone. It's me again, Karen from Devops Malmo. It's a bit awkward to sit behind the camera and don't see you shake your hands. I'm really looking forward to see you in at location at Foo Cafe, maybe some hybrid meetup to really see you and shake your hand, say hello to everyone. But since the time has changed, it's the new normal. So I just have to say hello from behind the camera. So really looking forward to meet you at location, and hopefully this thing will be soon over. Cool. So welcome to our next DevOps Malmo meetup. So today we have a small introduction about group and introduction from Capish. So let's count as 10 minutes as the first start meet and greet. All right. If you don't know, our group is also in social media platforms such as Twitter. We have a GitHub account. We use Instagram. So everywhere, as you can see, if you look for DevOps Malmo, you can find us in some social media platforms. But the best ones we are really actively posting and checking is meetup.com, twitter.com, and github.com. These are the ones that are really actively followed. And of course, since you know, we are always collaborating with Foo Cafe. So if you are just subscribed to newsletter of Foo Cafe, that's just enough. So you will get notification about our group and the coming meetups. So we don't have anything planned for next couple of months. So there was one that we actually wanted to do, but since it gets some delay, we have to say, so we will pause until autumn. So have a nice summer, enjoy the sun, if it will be sunny, so enjoy it. And if you want to know more information, just go to meetup.com, DevOps Malmo, and then you can see what's the plan. But after summer, we are going to have one another meetup. So just keep looking in the social media platforms. We will post there all the information. Cool. Before I go introduction about speakers, so since it's going to be everything live on YouTube, we are going to look actively under comments. So if you have any questions, anything just to post or ask, use YouTube. So we will just read, and I'm going to read all the comments you are going to write. And if there is any question, I will post it to Fredrik. Or if you have any question to Capish, also use YouTube to comment, and then we will check and then forward them. So that's it for me. So I'm really looking forward to see you in September. That's it for this semester. So thanks everyone. And I'm introducing you Dennis from Capish. So welcome, Dennis.
Thank you. Let's see. Am I in picture?
Yes, please share.
All right. Hi and welcome. My name is Dennis. I represent the development team of Capish. We have our headquarters here in Malmö, and it's a pretty cool company that maybe someone of you have heard about before. Really proud sponsors of tonight's event about the DevOps. If you're asking what we do, we work on a patented graph database system that we use for analyzing data in a special graph database format. And I will let you introduce us to our technology by showing you a short introduction to the system.
The whole idea behind Capish Reflect is to keep data and information in a conceptual, brain-mapped form that is easy to understand and have computers take care of the rest. That is why Capish products have a versatile and easy-to-use point-and-click interface. In any traditional BI tool made for slicing and dicing data, you will struggle immensely to zoom in on, for example, customers that have bought both products A and B, but not C. Or, from the little more complicated healthcare side, patients that take both heparin and aspirin, but not Pradaxa, and has a history of atrial fibrillations, but not stomach pain. For the human brain, these are simple, logical questions. And with Capish Reflect, you can easily pose such questions and obtain the answers yourself.
Okay, that was a short introduction to the system. And in respect to what we will hear on the presentation today, we have never thought about not having any DevOps tools, and we haven't thought about not having continuous integration, for example. So it will be really interesting to hear the talk from Fredrik later on. And we are always looking for talented people, and just check out our website at capish.com to see if you would like to apply for a job or something. We are always open-hearted here. So with this, I would like to hand over to today's speaker, Fredrik.
Yes, thank you. Okay, hello everyone, and hello YouTube. So thank you, Karen, and thank you, Dennis, first for the great introduction. And just like Karen said, I'm also really looking forward to the time when we can meet each other in person and having the chances to also mingle in between the talks. It's been a long time now, but we will get there eventually. So yeah, my name is Fredrik. I work as a DevOps engineer at IKEA. And so what does that mean? I work with teams and to help develop DevOps culture. And that can take many different forms. It can be helping to automate specific manual tasks. It can be building pipelines, or it can go into how we plan the work and how we get feedback from our users, for instance. So the full spectrum, you can say. And today, I would like to share an experience that I recently had in trying to find a good way of measuring how you perform as a software team when you are evolving in your DevOps culture. And as you will see, there were some difficulties and some gains and values along the way, and finally some lessons learned on this. So this will be a short story about my experiences. But first of all, I just want to mention why you should use metrics at all. Is what's the point? What's the value? I mean, if you have, just want to mention why you should use metrics at all. Is what's the point? What's the value? Dennis, I think you need to. So thank you. So yes, why do you need to use metrics at all? I mean, you can only just do the improvements that you find are useful, and you can just do them. And why is there any point to have some numbers that's showing you what you actually done? But I find that there are at least 3 reasons why it can be good to have some measurements. And the first one is that you can use them to sort of as a selling point. If you need to convince someone like product owner or some manager that you need to spend some time on some improvements, it would be much easier if you say, well, if we need to spend maybe 2 days. And let's say you have found out that if you do these 2 days and you spend this time, that will make you deploy from, let's say, once per 2 weeks to be able to deploy once a week. So that will be in, and that you can then use as a selling point, saying we will double our output if we spend time on this. Another one would be like for yourself, it can be confirmation on the changes that you do. So did you actually improve, and how much did you improve, and also how much more are you evolving as a DevOps team? So that you can also get. And the third one, I think, is something I will mention during my story here, is that when you do measurements, you can also, because maybe you want to hunt for these better numbers and better metrics, so you become a higher performing team, and that can force you to think in new ways on things that you maybe not have thought about before. So, but we all need a starting point, right? So going now into my own experience and my story about when I tried to perform and do some metrics on performance, I also had a starting point, and this was this one, and it's taken from the State of DevOps report. Some of you might recognize it. Otherwise, it's a big sort of research with lots of companies involved. And this, let's call it a model, is one part of this research, the result of it, where you have 4 key metrics that you use to measure the performance in your software delivery. And this was decided that this was what the model that we should use. So that was the starting point for me. But I like this, and it's kind of a recipe, and I like it. It's nice to have recipes, but it's not a full recipe. I know if you take the analogy into cooking, which I love to do, when you do something completely new, a completely new dish or a completely new type of kitchen, then, well, you might want to have every ingredient, and you want to know exactly how much of every ingredient, and you want to know every step that is needed to prepare the dish. But the more experience you get, the less you actually need this, and you might have your own flavors, your own seasoning, and your own kitchen knives and whatever, or ovens. So you want to be able to do it your own way, but it's nice at least to have some kind of guidelines. So I think this model shows in a good way what you need to measure when you look into software delivery performance, but it doesn't explain to you exactly how to do it. That is left up to you. But so if we then just look into how this model sort of works and what the different metrics are, we could say that these have 2 different categories. So the first category is more what I would say in terms of output, and it's deployment frequency and lead time for changes. And so the first one is, more or less, how often do you deploy to production? And the second one is when you have commit your changes and you're ready, it's marked as ready to be deployed, or at least ready, done in the developer sense. How long does it average, in the average takes you to get from that stage until it actually runs successfully in production? So this gives you a good view of how your output is. And the second category is more on the operational side. So we have the 2 ones. That the first one is then time to restore, and that is looking at if you have a service impairment in your production environment, something that impacts your users, how long does it take for you to get to like normal operations? What's the average time it takes for you to restore all of the services or fix a very serious bug, for instance? And the final one then is the rate of your the failed deployment. So when you have a deployment that causes something, this again, like service impairment, you look at the percentage of how many of these deployments you have. So this was, like I said, this was my starting point, and I wanted to start as easy as possible. So I just started on what I thought was easiest, and that was the output. So I started looking into then deployment frequency. How often do we do our releases in my team? How often do we deploy to production? And is there any way for me to look into the lead time? And of course, working as a DevOps engineer, working a lot with automation, of course, I started with looking into how to automate this. No, I did not. I started with this manually. I don't know really if that was a good idea, but at least I found it was not a big effort. So I just wanted the numbers. That's what I wanted. So for the first one, I just started to count, and I knew that we had our deployments and our releases. They were in a lot of different places. It was in our source control management, it was in our monitoring system, in our issue tracking, and in our cloud platform. So there was a lot of ways to find out how often we deployed. So I would just basically go in, looking in a different time span and just count 1, 2, 3, because we didn't have like 1,000. We're not Amazon, and that's not, at least not my team. So that was pretty easy. And then for the second one, well, then it started to become a little bit more difficult, since I couldn't just go in and count something, because what I needed to do was I needed to find, like I said, the average lead time for when something is committed until it's deployed. So I started looking at, okay, maybe I can look in between deploys and see how many pull requests, because we use pull requests. So let's say then that how many pull requests were a part of this deployment, and how much time did it take for this pull request to be open? Yeah, there were quite a lot. It was really not as simple as I maybe at first thought. So instead I reverted to just try to guesstimate, because my team, we worked in sprints. We're still working in sprints, and we're working on a 2-week basis. So back then, at least, we always deployed by the end of a sprint, and sometimes we deployed in the first week. So then I could say, okay, so worst case, 2 weeks, you have to wait. And in the best case, maybe a couple of days, 1, 2 days. So between 2 days and 2 weeks. That was fine for me, at least as a starting point. Then moving on to the operational ones, then it became very complex. Because now first of all, we have these 2 ones, and if we look at the first one then, time to restore. So I should look at how long does it take for us to restore a service? Well, then of course the first question was, when was the last time we needed to do this? Because it didn't happen that often. We didn't have database failures that often. We didn't have service breakdowns or cloud resources that suddenly stopped working. And we didn't have that many major bugs as well. So it was very much more difficult to trying to find this. Just out of sheer luck, one of our FTP server that we're using, it sort of stopped working totally. I think maybe got accidentally removed by someone. That someone being me, actually. I don't remember what I did, but it had to be restored. And there was not that many automatic things set up to restore it. So there was a lot of manual things needed to be done instead. And that took a full day to have it back and running. So out of luck, so to speak, when still trying to get these measurements, I had at least a worst case scenario that it takes us 1 day to restore. So that I knew, but then also, of course, that was not okay in my mind. So we worked in trying to reduce this as much as possible, introducing automation where we found these manual steps needed to restore this service. And we were able to at least reduce it by half. So we were able to find at least some changes that could do a big improvement on the worst case scenario we could think of when it comes to time to restore. And then for the final one, then deploy failure rate. Well, we knew at least it was easy to just count the number of deployments, but when was it failing? When should we count the deployment as failure? And where should I look even? Should I look in the pipelines that we use to deploy? Is there somewhere else I can look in? Well, we really didn't get a good number on this, but at least we knew that we didn't have so many impairments that often. So once again, it was just a guesstimate. So there was no exact numbers here at all. And I think I put something maybe like 10 to 15% of the deployments cost this. Maybe that was even lower. I had no idea. It was just a guess. Very rough estimate. So that was at least the efforts in trying to get this manually done. And of course, doing it manually, it had to be done often. And every time someone needed to get the updates on the numbers, you had to go in and for instance, count the deployments again. So yeah, it becomes tiresome. So, but at least we got a little bit of changes out of it. So when we looked into deployments, we had this, like I said, sometimes we deployed once per week. And this sometime actually led to always deploy once a week, because we started to look into why can't we do this every week? There must be something. What is different between when we can do it and can't do it? And when we found that difference, it was easy to say, make sure that we always will be able to have that possibility. And also, of course, always make sure that we do a weekly deployment. So that was one benefit. And then the same dimension, okay, that was stumbled upon by accident, that our worst case was 1 day, but at least we were able to reduce that by half a day. Because now we had the numbers and we wanted to have good numbers, of course, for ourselves. So yeah, but what if instead would automate this? That was like the next question for us, the next thing that we wanted to tackle. But of course, we did not want to continue doing this manually, and no one should, I guess. But since it didn't was much effort to start, it was okay. So yeah, the first thing I did was I just trying to reach out, see was there anyone else who had solved this using these metrics in our organization, has solved it in a nice way, and also looking outside of the company, because I thought maybe you shouldn't just. It would be nice if you could use the same solution, so we don't have to do our own solutions in every team. And I actually were able to find at least one team that had a very nice solution. They had much more resources and time put into than we were able to. So they have come much more further, of course. And looking at their solution, it was something that at the first glance was like, oh, nice, we can just reuse this. And we can just adapt it to our context. But as I will mention a bit more also during this story, the context is very important. How you like your strategies, for instance. How is your deployment strategy? Do you use pull requests or do you don't use pull requests? When you merge, what's happening? Do you trigger something directly after that? What is triggered and what does your pipelines look at? And other things as well. What tools are you using, of course. So, but in the ways of working, there was a little bit of difference between the team I reached out to and got help from, and my own team. But the idea how they solved it was the one that was interesting. And what I found was that they used a lot of information from their source control management. So they could extract data from like when they push, when they have opened a pull request or done something to a pull request, even deployment, and of course tags were also, and this we also had in our case. So this was something I hadn't really thought about before, that at least we're using GitHub, but this is true for, I think, every big source control management tool that's out there. That is sort of a database of events that you're doing that are most of the time based upon when you do some kind of testing, when you do a deployment, and when you, for instance, deploy to production. And looking into this more, it looks really simple, because GitHub has an API which you can call. So the only thing we needed to do was to write a function that could just fetch the data that we want and do some very simple mathematics on it, like looking at timestamps and comparing when something was deployed to when a pull request was opened, and then store this information that we calculated in a data source, and then use a dashboard to just display the data. And once again, now we only looked at the first two metrics, the output metrics. And to our surprise, it worked. And what was very nice was that it didn't take that many days. This was just like 2 or 3 days, I think. And we were able to have the solution up, and we were able to have a dashboard that could, in real time, tell us that, okay, now you have deployed something to production, and it's just a counter that increments, and also what the average lead time was. So that was super nice. So we had 2 down and just 2 to go. So just spend maybe then 2-3 days more and we will be all set. But of course, once again, it became a little bit more complex. The first ones were easy and simple because we had all the data available. And I would also say that the first ones, it's easier to know what you need to extract. For the other ones that we have here again, time to restore a service and the rate of your failed deployment, a lot of questions came up again, like what is a service impairment, first of all? When we lose performance, for instance, for our users, when our application becomes slower, is that a service impairment? Or when our app crashes, is that a service impairment? Where should we draw the line? This was unclear to us. And also, what is a failed deployment? Is it only when we found a bug that we want to fix? Is that a failed deployment? Is a failed deployment only when a critical hotfix is discovered that we need to fix immediately? And what we settled at was more or less that, well, let's say that a failed deployment is when we find a bug that we need to fix straight away. And also the time to restore we kept as it was before. We just looked at the worst case scenario, having to set up a service that gets destroyed or something. But we had a lot of attempts trying to automate this, and we looked at a lot of different ways into looking into our services, looking into when these are discovered. And this other team that I looked at, they were directly, like, they were having checks and looking at their services, and if they were up and running, everything was okay. If they were not okay, then the previous deployment was a failed deployment, and then hopefully the next one, or when the health checks will be green again, then you have made a successful deployment. But we couldn't really fit this into our context, and time just flew. I think we spent maybe, I don't know, up until a month or something trying to figure out exactly how we should do this, and not maybe 8 hours a day on this, but at least in lead time. So there was not much progress made, and we sort of had to sidecar this because we really didn't find a way forward. At least we had the 2 first ones, the output, we had that automated, we had that visible anytime we wanted to, and we could at least try to get better numbers there. But for these other ones, the operational ones, it was still not clear for us. But then we sort of stumbled upon another solution that it's actually made by the Google Cloud platform. So if you're using Google Cloud, or if you just want to check out a solution, a complete solution into measuring or having these performance metrics, then I would really recommend looking into this. It was not 100% compatible. Once again, the idea or the people behind it, maybe they are used to working in a certain way with, for instance, deployments and commits and pull requests, and it didn't really fit our strategies. But again, also the idea was interesting, but at least it looks pretty. So what you get from this is a complete dashboard as well. It looks like this. So you get all of the metrics there, and you can see when you do a deployment, and you get a sort of if you have a weekly or daily deployment, for instance. So you get a lot of free stuff. But if it doesn't 100% fit your strategy, then maybe you should do like us and instead look at ideas. And so what was the idea behind it? Well, the thing that caught my eye was that they used the same kind of approach or similar approach that we did with our custom solution. So they looked at the events produced in your source control management. So in our case, GitHub. But instead of querying the API, it sends a webhook each time. And then you have a listener on the other side that listens to these webhooks and listens to these events, and then can filter out the events that it wants to listen to, and then transforms the data. And once again, it stores in a database, and then you have a dashboard that shows this data. So quite similar to, but much more complex in a positive way, of course, and a bit more complicated solution that our original one. But at least this one could handle all of the 4 metrics, when our custom one only could handle the first 2. And so, of course, that was the most interesting part to me. So how did they solve this? Well, they solved it pretty easy. And now when I'm going to explain it, you might think that, well, that's a given. But in the time when we looked into and we did our investigation, it didn't look so obvious. But what they did was that they looked at incident reports. So for instance, in GitHub, if you create an issue and you mark it as an incident, then that will also be sent as an event. And this event handler will then say that, okay, this is a service impairment that occurred because you have created an incident. And inside it, you can also target a certain deployment by marking it which commit that was deployed recently. And when you then close the incident, when you then mark a commit, which is then a deployment, then you know this was a failed deployment because this is sort of the root cause. And when you close this incident, the time before when you deployed and you close this incident is, well, that's the time to restore. So of course, this maybe not be fully automatic, but when you get a service impairment, when there is something, a critical bug that is detected, I'm guessing that everyone sort of always creates some form of ticket, some kind of incident gets tracked. So why not just look at that data and use that? We had a little bit of discussion in our early stages if we could look at our issue tracking system. Fortunately, we couldn't talk to that. We only had GitHub available. So maybe we would have thought of this earlier. I'm not really sure, but I don't know. But since we couldn't, that idea never really came up. So like the almost complete solution then that we ended up with was that we could fetch deployment from directly from GitHub, just counting sort of the same way that I was doing manually. And then for each commit in a deployment, we just calculate the time between you have a pull request open until that deployment was deployed. And then for the final 2, we're not really fully there yet, but we're looking into this and then creating some kind of incident and marking out deployments that are the root cause for the incident. And that will then be our rate of failed deployments. And then as soon as we then close an issue, we can look at how many on the incidents that are closed, and then look at the time between the deployment that is marked, when that was made, and when the incident was closed, and then we have our time to restore. So probably it's going to be much more simpler. We don't have it. It's like that's why they almost is there. We don't have it fully there yet, but now it's perhaps going to be like simple. If this is going to be enough for us, if we should not maybe look more into actually the operation side into our platform, well, maybe we should, but maybe we don't even. It's all at the same time. Maybe we don't have to. Maybe we can only look at these kind of tools and get that data from there because it's stored there and it's saved there forever almost. Like so, yeah. So yeah, that was the story. From beginning from a manual way of looking into this and all of the questions that came up and all of the complex ways of trying to automate this and finally ending up with a solution that sounds very much more simple than maybe we at least from the beginning thought that it could be. But of course, we also learned some things. And I would say the first and foremost was that using the data that's directly in your source control management, it gets you going really fast. Looking at, once again, pull requests and other events that you might have there. You can do really simple API calls and just extract data and do any calculations on them. And as we saw very early, was that even though we didn't have everything set up, when we at least started with these metrics, we also started to look into how we can improve some things and how we can do a small change that would give us value. So we were able at least to do some improvements on our deployments and how we can restore our services if the worst case happens. And this, of course, has continued as well. We have continued to look into this and producing better numbers, at least trying to. And there are a bunch of other solutions that you can find. But what we learned really that even though it's really maybe it looks pretty and it looks like it's almost fit your case and maybe you can just adapt a few things, it's still better to look at, okay, what's the idea behind it? What was the initial idea into this specific solution? Because there might be that the strategies that the persons who create the solutions might have a different perspective than you do, or different strategies. And why not starting off manually? It was not a big effort for me, but in some cases it could be. If I would really try to get the exact numbers and everything, that would be a huge effort. But as soon as it becomes a huge effort, then you should not do it manually, I would say. Then you should try to find alternatives. And it's nice to have a recipe as well. Not a full one, but at least something to have as a starting point. Yes, thank you for listening. And I'm not sure if we have, I think we have some time for some questions. So do we have any questions? Yeah, we have someone here that mentioned that it looks like the metrics discussed in the book accelerate. Yeah, that's correct. Same as Nicole Firstgren and the other and company there. They are the same people behind this State of DevOps report as well. So that's true. It's a very good book. So if you haven't read it, you definitely should. Any other questions? No. Then perhaps maybe some question from you, Karen.
No. Thank you, Fredrik, for today's presentation. And thanks everyone for attending. I also want to thank Fukafe and looking forward for September. So we will have something new, maybe new way of doing something. And thanks Capish for sponsoring today's event. So take care, everyone. See you after summer. So good luck. And yeah, that's it. See you around.